Okay, here we go. Yeah. All right. Good morning, everyone. Yay, week 10. You've almost finished your first term. That's exciting. And now is going to be an exciting week ahead. No new material, which is even more exciting. So we're just going to be doing a lot of questions and doing a lot of practice stuff today. And then I'll also show you what the exam environment looks like so that you are not surprised when you get into the tute labs. And also for those of you that are online and will not get a chance to come into the labs to actually see the environment, you will get to see it as part of this recording, I guess. Okay, also someone's asked what are the lab exercises for this week. The lab exercises are the prac exam. So once you log into the prac exam, that will be your lab exercises. And you don't have to do them all to get full marks for this week. This week is a gift to you all to prepare you for the exam, which will not be a gift. It will be not that at all. Okay, here we go. Okay, so first things first. Let's just quickly, where am I? Here am I. Okay, so last week we did multi-file systems, we did some linked list questions, and this week we're going to just do revision, as I said, so it's going to be a good week. Live lecture code, they'll post it in the chat once we start doing anything. My experience surveys, broken record, but please do my experience surveys. You will also get some time in your labs this week to fill them out. We use the feedback that you provide in them to improve our course and make it better, hopefully for those that come after you. And yeah, we really do value the feedback. Okay, revision classes as well. In week 11, we're going to have 2 classes to start with. If they fill up, we will put on more classes. So based on demand, basically. Face-to-face is going to be on Monday, 2 till 4, and online on Wednesday, 10 till 12. If you can register for them using that link below. Someone's asking where is the email when you can pick out your times for the exam. I don't send out that email. It's coming from the school and it is coming sometime today. As you can imagine, they are sorting out quite a few lab run exams. There is a lot of things to consider, which is why it might not have come out yet, but it will come out and you will get a chance to preference whichever exam slot you want. In all my time with face-to-face exams, I've never really seen anyone miss out on whatever preference they want. So don't worry, everything will be okay. That joke in the chat is not funny, the function with the leak exam. It has happened. The final exam was by accident released as the prac exam a few terms ago, and then we had to rewrite the exam, so it's not funny. Yep, good times. Okay, no, revision classes are in week 11. Okay, here we go. This is what the exam environment will look like. So you will go into the labs, you will log in normally, then you will press, you'll be in the exam environment. It'll take a good old age to load up. Yep, still going. Here we go. You will get an interface that looks like it was designed, 40 years ago. Appreciated for what it is, even the fonts. It's like you've traveled back in time. You'll get basically a few keys that you can click, and then you'll press OK. If you right-click on this screen, which is amazing, look at this. The options you have. You will have the questions here. Don't worry, it's loading up the practice exam. I checked before this lecture. Okay, so you'll see the practice exam for this week, and then you will also have the course website available to you, and everything on the course website will be available. So if you go to week 5, you'll be able to see the solutions as well, and all of that as well, and the lecture code. Okay, you will also have available to you all the stuff on this website. So things like the cheat sheet, as well, the reference card, all of that will not be locked down. You will have access to all of that. Then, okay, you will have access to a few editors. VS Code is set up in exactly the same way as it is right now for you as well. So you'll be able to use it as you do normally. And what you will see is if you open up a terminal window, if you do ls, what will happen is you will have the starter code for all of your files sitting inside your home directory already. You don't have to think about it. Well, I mean, just have to think about it slightly, but not too much. So they will all be in there ready for you to go. What else about this? There was something else that I wanted to say about this exam environment, and what was it? What was it? Oh yes, I wanted to say, so please read through the information that's provided before the exam. Okay, it's going to be exactly the same. It's going to be exactly the same as the information you'll see in the test as well. Now, the only thing you'll need to know, just keep in mind, to auto test questions in the exam, you'll run auto test, and then in this case, it'll be prac question 1 or prac question 2. In the exam, it will be exam question 1, exam question 2, and so on. And then instead of give, you will use the command submit. So you will press submit, and then whatever the question that you would like to submit. And you can also check your submissions have been accepted by running a show submissions command as well. Now, if you walk out of that exam and you are feeling, I think I've forgotten to submit all of them. Has happened, not the first time it's happened. Please let us know immediately because we can help you, okay? So, but please check your submissions and make sure to submit multiple times, okay? As you can imagine, at the end of the exam, there's a bit of a rush to submit, and sometimes that means that the submission will go through a bit slower whilst it's running through the system. So please just submit as many times as possible. Okay, excellent. Someone said there are 4 dots. So the last question is a mixture of 3 dots and a skull, and it's really, really painful getting a skull to show up on this interface, which is why there is now a 4 dot. But basically it's a mixture between a 3 dot and a skull, and that's the question that you may or may not get to, but this is just for you to see the level of difficulty of that question, and if you wanted to attempt it, you can as well, okay? You will see all of these questions today, okay? So you'll have, or not today, like over the course of this week, when you log into your labs, you will see lots of these questions. And the first 4 are, you know, the 5 markers, and then you'll get the onwards, you know, the more marks. Okay. Anything else about the exam environment whilst I'm on here? Yeah, you can keep submitting. Is this practice exam a good indicator for the final? Yes, it is. The questions are of similar difficulty. Yeah. Do you get something to write on? Yes, you do. You get scratch paper. Each one of you will get 1 page. If you need more paper, just raise your hand and you'll get more paper. Yeah.
What's the average mark of this exam like historically?
It's hard to tell because this exam has changed format quite a few times, as in it was online 6 hours, then it went to 3 hours open book, and now it's closed book 3 hours. Minus an extra question. So, and it used to have 20 multiple choice questions that were not really multiple choice and that were very hard. And now there's 4 5-mark questions that are significantly easier. So it's hard to say what was the average before. Some people do very well and some people don't do very well. Let's put it out. But the best way to do, so there's no tricks in this exam. That's the one thing, you will not walk in and you'd be like, I've never seen a question, especially in the first 8 questions. You will not be like, I've never seen any of this before. That's not going to happen. The last few questions are going to be a lot trickier, but the first few are going to be questions like we practice in the lectures, like you practice in your, in your problem sets and so on. They're not, there's no surprises. Any other questions? I really don't know what else to say to reassure you. Bring some water, please. Do eat, yes. And you can't leave the first exam if you're in the morning session, actually. You will not be able to leave. Even if you finish and you don't want to be there, you have to just chill in the room. Yeah. So, sorry. You can only leave early the afternoon exam. I've never really seen anyone leave early, so it shouldn't be a problem. Any other questions about the exam? I know you're feeling a bit nervous, but I promise you it goes by very fast. Yeah.
Where do we register for the exam?
It's coming. It's not out yet. It's coming.
Where would we find it?
Hey?
Where would we find it?
It'll come to you as an email with a link. Yeah. No snacks. I'm sorry, there's no snacks. No one who's working wants to hear chips being crunched or apples being crunched. It used to be, yeah, back in my day, people used to blow their noses, and that was quite annoying as well. Okay, any other questions? I promise you'll do all right. Yeah. No, not to the ones that you did yourself. But you'll have access to the sample solution code for the labs. Yes, so for those people that are online with online classes, you have been known to, no, you haven't been known, but you've been given an opportunity to come in, to register to come in to try out the exam environment, and I do recommend that you do to make sure that everything works, okay, for you when you actually come in person. Yeah. You have to use the CSE computers. Sorry, I know the keyboards are horrible. We will wipe down the keyboards before the exam as well. I know they're horrible. You cannot bring a keyboard because for those that have mechanical keyboards, those are also really annoying. Yeah. Yeah. Apologies, that gets asked all the time. You can't bring your own keyboards. But everyone is on the same level of using the same crappy keyboards. So, okay, anything else? Auto tests. So remember what I said about auto tests. There are auto tests, but they start to dwindle when you start moving on in the exam. Okay. No, you will not. VS Code will be locked as to what it is. I don't know, band C features, depends what they are. If I see you using go-to statements in your exam, it makes me twitch. But yeah. Okay, all right, I think that's, oh look, someone's been practicing by using a crappy keyboard the whole term. That's clearly the solution to this dilemma. Okay, excellent. Let me log out of this beautiful environment that you will be seeing quite a bit, and I'm sure you're well excited about. Can you use Vim in the exam? You can if you want. I mean, how sadistic are you to yourself? But you can, of course. No one's stopping you. There is Vim available, and there is also gedit available, because if one of those editors crashes, and it has VS Code has been known to be a bit temperamental, if it does crash, you will be able to have a different editor whilst we force kill processes on your computer and stuff. Okay, excellent. All right, yes. Okay, good. Okay, I don't know what's going on. I'm going to leave that chat to you guys because I'm getting distracted by it. Okay, excellent. Okay, linked list. Today we're going to do linked list revision, and then on Thursday we're going to do pointers, strings, arrays, and a whole bunch of other things, maybe some more linked lists depending what you guys want to do. But we're really just going to have fun today with linked lists. Someone thinks they're being smart on the chat. They want pointed to the right direction in life. No, cannot give you that. Okay, so linked lists can only access things sequentially by traversing the whole list. You can add in notes as needed because a linked list is a dynamic memory allocation structure, and you just use malloc to give yourself a node, and then you use free to delete that node and to free up that piece of memory that you have created. You can also check for memory leaks, and that just means that you've used free for every malloc that you have done, and you have given back all the wonderful memory that you have allocated. Okay, with linked lists also, please make sure to think about the boundary conditions when you are doing your programs. So in the first few questions, not as obvious, but once you start inserting, deleting, it becomes a lot more obvious when you miss out a boundary case. So always check that your program works for empty lists when there's nothing in there, that it works for something with one element depending on the context of the question. What if something happens at the head of the list or at the beginning where you replace the head? What if something's happening at the end of the list where you're replacing the tail, or where you're inserting or deleting, at the tail end as well? And what happens if something will not occur? So for example, you're searching for something that's not on the list, that you are kind of taking care of that as well. Okay, I've got this question, but I can just do it in the linked list file that we were using before. Actually, let's start with this question here. Okay, and what we're going to do is we'll do one question together, then I'll give you one question to work on yourselves for like 5-6 minutes. You can raise your hands. Tom, Sophia, me can walk around as well, and so on and so forth, and we'll move from 1 dots to 2 dots. So this kind of question is similar to a question 6, which is like a simple linked list traversal question. Okay, find the range, the difference between the biggest term and the smallest term of a linked list. So you will get it's working, amazing. Okay, so you will get something that looks like this. Your task is to add code to this function, list range, blah, blah, blah. The question uses the following familiar data type, and it's given one argument, blah, 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 blah. And it should, Okay, so you will have Yes, good. Okay, so you will get something that looks like this. And actually, this is a good chance for me to also show you what these files look like that you're going to get in the exam, and how you can test your code as well. Okay, you'll get something that looks like this. You'll get a struct already there. All you'll have to do is basically this function that is going to be in the file. Then you'll get something that looks like this. Do not change the code below, please don't. A few people do every single term. And then it breaks all of their code. And what this file does, basically, what our main does, is it actually reads in a linked list so that you can test from the command line. You don't have to do any of that. All you're doing is the function that's calculating the range. But what we're doing is we're reading in the list that you put on the command line and turning it into a list. Then we're going to call your function what is needed, and that means that you are not going to fail the auto test for forgetting a space or a new line. Yeah.
So we want to pull up like the original code, like say like if we edit the code, we realize we don't want to like use this code anymore. We want to return to original state. Is there a way we can pull up the original code?
Oh, I see what you're saying. Hey. Oh God, in the new exam environment, is there a way to do that? I'm sure we can. Just raise your hand and we'll solve it in the moment. We can shove things into your account, but we'll just need your The exam environment's changed again. This one's been dusted off. Okay, and then this function is the function that actually you don't have to understand it, you don't have to do anything about it, please do not change it, but it's just going to read in and make a linked list for us so that you can test with it. All right, so let's do this code here now. Okay, how would we solve it? How would we solve this type of question?
Find the minimum and the max.
Find the minimum and the maximum. Yeah, what a question. Getting you to find both. And then we just subtract them from each other. Yeah? Okay, let's do it. Okay, so let's say I'm going to read in a list that's going to go 3, 4, 6, 7, 8 or something like that. Okay, and what this piece of code is given, it's given the head of this list. Okay, so you can see that the function is receiving the head of the list and it's going to return an int because it's just going to return the actual range of the list. Okay, so I'm going to have some sort of minimum, I'm going to have some sort of maximum, and then I'm going to need to move through the list, which means that I'm going to have a current node, and I'm going to set it to the head. Okay, excellent. And then I'm going to traverse the list. Okay, so how do I traverse the list? I need to have some sort of condition in there, and then I'm going to move my node along. Okay, good. Now we've done a lot of finding maximum and minimums. Who remembers what's a fun way to do it? Bless you. Okay, fun way. Well, I don't know. Every way's a fun way. That's whilst fun, it's true. We haven't done recursion in 1511 this term. The only time we actually get a chance to cover it is in term 2 when there's no public holidays. Any other way? Go on then. Just feel the week 10 vibes. It's all going to be over soon.
Are we just trying to find
Just the minimum and the maximum of the list.
at the same time, or like?
We can do whatever you like. We can find it at the same time. We can go through it again. We can not do it at the same time.
We just start at the head.
Yeah, we do start at the head. Yeah, I agree. Will we go through the whole list or will we stop at the last? So will we do current or current next?
Until,
Yeah. Yeah, good. Okay, someone's saying online they want to do 2 different loops. You can do 2 different loops if you want. You can do 1 different loop. Should we initialize our minimum and maximum?
Yes.
What should we initialize them to?
Head data.
What?
Head staff data.
Amazing. Okay. So what we're going to do is we're going to initialize each one of these maximum and minimums to the first item in the list. Okay?
well, we have to check if it's even, if that is even initialized.
So what is the first thing? I did keep talking about boundary conditions, but thank you very much. Okay, what's the first thing I should do?
If head does not.
Yeah, what happens if it's an empty list?
Return 0.
Yeah, okay. So the first thing I want to do is I want to check if head is equal to null because it means the list is empty. Okay, and then I'm going to return, and if you look up here, I have a hash defined to return. It's called empty list. So I'm going to return empty list. It's minus 42. It's not even the meaning of life. It's just something else altogether.
Surely the range of an empty list would be 0.
What?
The range of an empty list, wouldn't that be 0?
It is 0, but I'm contriving something to show you that sometimes it will have this. And it will ask you to be returning the list is empty. That's why. So read the question is what I'm contriving here. It will tell you all the assumptions that you need to make. Okay, so if we pass this condition, which means that there is something in this list, then that means we can start pulsing through this list. Okay, so that means when we start moving through here, we're just going to check if the current data is less than min. Then minimum is going to be current data. Yep. I really hope that's a less than symbol. It is, isn't it? Yep. Every time. Week 10 is a really hard week. I don't know how you guys get through it. Okay, and what about the max? Okay, we can check an else if here, and we can, oh God. We can check that current, or if current data is greater than max, then we're going to say that max is then current data. Okay, otherwise we're going to move along. Okay, and then in the end, we're going to return max minus min, and then hope for the best. Okay, so let's see how we test it then. Okay, so let's compile it first. Okay, it compiles all right. So now to run it, because remember I said, yeah.
You can start current and head next.
Pardon?
You can start current and head next.
I could, that's true, yes, because I've started counting at the first one. Yes, that's a very good point. Excellent. Okay, so if I'm going to run this, then what I'm going to do, I'll do that after I run this, so I don't have to save again. I'm going to read in the list, so I can put in any list I want in here to test what I've got. So 3, 4, 6, 7, 8. And if I run that, then it's going to give me that the range is 5, because it's 8 minus 3, which is the correct answer. What if I do 10? Then it will give me 7. It's the correct answer. What else should I check?
Empty list.
Empty list. Excellent. So what happens if I just run it without a list? It's going to say the list is empty, so it's doing that correctly. Anything else I should check? One value. Lots of these questions will make you sad. Anything else I should check? Oh, thanks, Sophia. No. Exams, you know what? It's going to be a fun exam. Yeah. Hey? Negative numbers. I think this question says assume it's always going to be positive. I can't remember. But it's still doing it all right, so it's fine. Yeah. Excellent news. All right, so that seems to be working, isn't it? Maybe it is. Yep, good. How is everyone feeling about this type of question? Thumbs up, 2 thumbs up. Anyone else? Another thumbs up. A thumbs down. Oh, anyone else for a thumbs down? No, only 5 people are communicating how they feel. I'm so pleased that someone is in touch with their emotions. Okay, great. Let's do one that is, let's do another one. No, that's not where I meant to go. Where am I going next? Here. Okay, concatenate 2 linked lists. Okay, join one linked list to another. The reason we're doing this one is so that you can see what happens if we have to read in 2 lists. Okay, so I'll show you what that code looks like. So, all that this question is asking, despite these beautiful diagrams that might be throwing you a little bit, is just given 2 lists, 10, 11, 12, and a list 25, 26, 27. You join them together to make one big list. Okay, so join the second list onto the first list and have one big list. That's all it's asking. So concatenate 2 lists. And then it's giving you should still work if the list is empty and should still work if the second list is empty. Okay, so let's have a look. So in a question where you are potentially getting 2 linked lists, you will see that the function that you are writing is taking in 2 heads. It's taking in 1 head, it's taking in head 2, so for the first list, for the second list. You don't have to worry about creating the lists, okay? The lists are going to be created for you, again, in a function that is do not change this main function and do not change this function strings to list. That is what's going to create the lists for you. You don't have to worry about it. Again, we're printing it out for you. You don't have to worry about that either. All you're doing is writing the function that will actually join the 2 lists together. So given 2 lists, join them together. Okay, let's put our code here as instructed. Okay, and this function is returning a struct node pointer. Why is it returning a pointer to a struct node? Yeah, because I might be changing the head. Okay, so that is why I am returning a head in this case and not just nothing. Okay, what it means is if I have a... And Tom, can you please do a poll for the first question? How are we feeling about it? So let's say I have list 1 and it's got 4, 5, 7, and I just type 6, so 6 it is. And then I've got a list 2 that has 7, 8, 9. Then what I should end up with is a final list that's going to go 4, 5, 6, 7, 8, 9. Okay, what are we thinking about this question? How should we solve this? Anyone? Anyone? Beulah? Yeah. So traverse through the list until you're at the last node, and then, yep, Bob's your uncle. Okay. So nope. So the first thing I need is a struct node current. It's going to be pointing to the head, except that I've got 2 heads, so I'm going to need a current 1 and a current 2 potentially if I need to pulse through the second list, and I'm going to set it to the head of the second list. Okay, so what that means is I have something that looks like this, where in here now my head is going to be the node with 4, and here the head is going to be the node with 7 on it. Okay, so what I'm going to do is I'm going to pulse through the first list and add the second list onto the end of it. So that means, where will I go? Will I go all the way to the end, or will I stop at the last node?
Current one next does not equal to null.
Okay, so we're saying we're going to go until current next is not equal to null, because that means that we're going to stop at the last node, which means we're going to stop at 6. Because if we go past the end of this list, and let me draw it, because if I can just, here we go. And what I'll do is I'll clear this so that I have some space. So let's say we've got So I've got a list that is, oh my God, it's completely off. The pen is completely out of calibration. Okay, so I'm sorry in advance. That's not bad. The mouse is for suckers. I'll recalibrate it at the break. Here we go. Okay, so this is my first list, this is my second list. I'm currently standing here. If I go past it to the null, what's going to happen is I won't know what to connect, okay? Because I need to connect this node to this node, so it's going to be my next node through. I'm currently over here, which means that I want to stop when current next is equal to null. So I want to stop when the next one from the current is going to be x. So I want to stop here, because then I'll change the next of this one to be the address of where the 7 is. Yeah? Okay, so whilst current next is not equal to null, what I'm going to do, and this is also wrong because it should be current 1. So then current 1 is going to be moving along, so current 1 next. What that will do is that will mean that when I come out of this loop, I am going to be standing on the last node of the first list. And that means I am now ready to join the 2 lists together. How should I do that?
Say current 1 next is head 2.
Yep. So current 1 next is going to be equal to head 2 or current 2, whatever you like, right? However you structured the question. So what that will mean is I will create this joining over here, and then I will return something here. What should I return? We haven't considered any boundary cases yet, but that's okay. We'll just run it for what it is. Yeah, okay, so I'm going to return head 1 to, yeah, okay, let's have a look. All right, so I'm going to save it, and now I'm going to compile it. Okay, so now to run it, okay, this is how the two lists are created, okay. I'm going to do 4, 5, 6, 7, no, that's not 4, 5, 6. Then you put a hyphen, and that's what's going to know that you finish the list and start the next list. So all you do is put it in like this into your command line arguments, and our function will create the two lists for you, and you don't have to worry about that. And then I'm going to run it with that, and it's going to create 4, 5, 6, 7, 8, 9, X. Excellent. So it's working for that list that we kind of perused. How can I test the boundaries now, whether it works for those?
Empty lists.
Yeah, let's do one empty list. So I'll do the first empty list and then just the second one. Okay, great. That does not work. Okay, so that's one case that's not working for us. What if I do first list, but not the second list? That works okay. Okay, why is that situation happening?
If you check the current one, it's already null.
Yep, so over here I've set my current one to head. It's actually null, and here I'm actually returning head 1, which is null right now. Okay, so I need to stop that from happening. Okay, how will I do that? I can check over here if my head 1 is equal to null. And if it is, then I'm going to return, what do you think I'll return? Head 2, excellent. Yep. Okay, so let's see if that's now solving our issues. So I'll clear it again, and then I'll compile it. And let's run it with nothing in the first list, but a second list. Okay, so now it's working fine. What else am I going to do? How else can I test it? Except for just typing auto test. Pardon? What? Sorry, there's like a few people speaking at the same time. And so both of them are empty. That's a good one. Okay, let's try that. Both of them are empty. And it's, yep, empty. Good. Anything else? No? Okay. We think that's looking good. All right, let's do a similar type of problem. And then we'll walk around. What's the time? 11:44. Okay, great. I've saved the 2 dots for after the break, just to give you a bit of energy. Let's do this one. Length difference. So I think I've got, yeah, I've even got the starter code for it. So you've got 2 lists, let's say one's got 5 nodes, one's got 3 nodes, return 2 as the difference. And fill in the dots in there. All right, so let's do that. Let's do 7 minutes. I feel like I'm timing you for the HSC, like getting you to practice doing questions fast. Sorry. And raise your hand if you have any issues.
They said it's like.
It's like
You're desperate.
If they're using a breakdown, it just keeps going. You should write a solution.
Pressure, break out.
it's harder for us to see what we were trying to do. Well, it's like it's better for very small. Very hard. So it's better to just consult with they probably try something don't waste time. Try to solve it with yeah.
True, yeah.
Unfortunately.
Oh no. Sliding on the side face to my mom.
7 days for one student.
Yeah, that's right.
24 hours a day.
All right. How are we feeling? Are we feeling? Are we not feeling? How are we feeling? Everyone's feeling? Everyone's thumbs up? Excellent. I did leave you on a sort of easier question, I guess. Do you want me to solve it? Yeah? Okay. What am I doing? I am finding the difference between the number of nodes in my two linked lists. Okay, how shall I do it? What are your thoughts? Yeah?
Just like initialize two variables for the length
Okay, and then I guess I'm going to move through the list and count up how many nodes there are. I guess that seems like a good thing to do. Okay, how should I move through the list? What should be my condition? Am I counting at the same time or am I doing two loops?
2 loops.
2 loops? Okay. Sure. Okay. Should my condition be not equal to null or, no, well it should be that, but should it be current 1 or should it be current 1 next? Current 1, perfect, because I want to count every single element in the list, okay? Why not? It's gotten to week 10, it's chocolate for everything really, but maybe we should just spread the love a little bit as well. Okay, so I'm going to increase my length and I'm going to move along in my list. And if I'm going to do a second loop, I'm going to do it with current, oh my god, current 2 is not equal to null. And then okay, excellent. Okay, and what should I return?
Length 2 minus. Length 2 minus length 1.
What happens if it's, okay, we're going to go length 2 minus length 1?
Wait.
How will I, what if the list, the sizes change across? How will I, as in like, what if list 1 is 5, list 2 is 3, and I'll return list 2 minus, what if I have a negative basically?
It's fine.
Okay, let's do it. Okay, yep, list, no, that's not what I'm returning. Length 2 minus, oh my god, length 1. Oh my goodness. Wusa. I'm a lot more generous in there.
Could you just change the function to return a
Hey?
Could you just change the function to return
I mean, don't change the return type of the function, please. I mean, that is the fast way to do it, but don't do that. Okay, let's compile. Which problem is it? Okay, compile spine, and I need 2 lists, so I'll just do that. And 7, 8, 9, 10. Okay, it's returned 1. Okay, what if I do like that? It'll return -1. How do I get rid of the minus? Yeah.
If it's less than 0.
Sorry? I could also just do an absolute value and return that. There we go, and then it's faster. Okay. Okay, so then it will return an absolute value of it, as opposed to giving me a negative number. Okay, how are we feeling about the difference problem? Tom, Paul, thank you. Already done, amazing, on top of it, okay. Good. I want to see everyone like raging with confidence. Oh my God, in the last one, people were like raging with, no, it's only 30 people voted. 30 people were raging with confidence for question 2. Okay, what else can I check in this list? Should we check empty lists? Let's do 2 empties. Yep, 2 empties is fine. What if there's one list and nothing in the other? Still fine. Things are going well for us. Anything else? Nope? Okay. All right. Does this feel like a good time for a little break? Oh, what about this one? Let's do this one quickly. We've got 5 minutes. Yes. Okay. In this question, you will be returning find divisible by 6 should return the number of items in the list that are divisible by 6. Okay, thoughts, ideas, suggestions?
Counter.
Yep. Let's do a counter. Let's make it equal to 0. Let's have something that we can move through the list with. No, don't use head. Yeah.
Traverse the list.
Traverse the list. Oh my God, it's like there is a method to the madness. Okay, while current is not equal to null, so that I get a chance to go through the whole list and not miss out any elements. What am I going to do? Yeah, so let's check if my current data, so if the data point modulus, oh my God. Okay. Oh, smiley face. Yeah, that's what it was, and then yeah. Then the smiley face distracted me. Bonus marks for leaving smiley faces in the exam. No. Yeah, then I'll move my counter ++. Excellent. Otherwise, I'll keep moving through the list. So current is equal to current next, which will move you through the list. And then for the final hurrah, I will return. What will I return? Counter.
You will change the functions to return instead.
Oh, why is it? Yes. Just close your eyes. It shouldn't be returning that. It should delete. Oh, I know why. Because I'm going to use it. Because I'm using it in a further example for a 2 question. Okay, it's okay. Let me just quickly make it possible to return it here. Okay. I forgot what the function's called. Delete. Because the next question, the 2 marker, is deleting a divisible by 6. Yep. And that's why now I'm having, where did I prototype it? Nowhere. If anywhere, here we go. No, we're good. And then it's, oh, what a disaster. Anyway, just trust me, it works. Yeah, trust me. Who trusts me in this room? Okay, 4, 5, 6. 8. Okay. Oh God, how awkward. Don't trust me. It's returning the wrong thing.
Oh my gosh.
Oh no, it's not. It's returning the right thing. I'm dividing by 4 in my head. I'm like, it should return 2. Okay, let me try nothing. And let me try one more thing that's divisible by 6, 2. Excellent. Okay, it is working. Trust me. We're back to trust. Okay, let's have, you do have access to all of these files. They're in the week 10 lecture code. Okay, let's have a 5-minute break and then we will come back and we'll do the 2 dots as well, which no doubt has everyone super excited. GCC with a few things in it, but it did break quickly, but we fixed it. I feel like every time I push something, it crashes everything. Don't. Okay. Let's keep going. We're slimming down in the theatre. It's all the feels for the, as someone put, impending doom. I feel like impending fun. You're almost done. You're almost ready to move on. Okay. Oh God, I even had a fake Kahoot. But should we do it? Should we do a fake Kahoot? So little of you. Is anyone else going to leave this theatre if I do a fake Kahoot? I just can't take that anymore. Okay. Oh, yes. Okay. Should we do that just to wake up a little bit, then continue with our 2 dots? Yeah? Yeah? Like 5 or 6 questions. Come on, let's do it. Did you enjoy your first taste of programming? Did you? Okay, here we go. I think I can control it from here. No, I can't. I've got to run it from here. Maybe. Where did I put it? Here. Sophia, could you just play us some music, just for the, I don't know.
But can't be
No, just play like the, I don't know. Play Kahoot music to complete the whole vibe. Okay. Wow, that's like so pointed. Hey?
Really want it, it'll get copyrighted, the lecture will get taken down.
I should have made you sing.
Don't even go there, I used to do so.
Oh, you've got talent. Why aren't you singing for us?
Like 4 years ago.
All right, let's do it. Here we go. Here we go. Hey? You know, it'll still compile fine. It's just once it starts to access it, it will not like that. That music is so annoying. Testing your eyesight as well, just to make sure you're ready for this exam.
Sorry, there's an ad. Off the bar.
I don't want to listen to this.
Yeah, where's the
They stole Ben. new music that you chose for us, Sophia? Wow, okay. Someone's leaving. That is literally killing me.
What? It's the same pitch. The pitch is the same.
Yeah, sorry about that.
Just chose around. Oh, I got it right.
Just testing if anyone's still paying attention. Oh, look at that! Oh, there we go. Throw some chocolates around. Come on, people are so. Have you opened both of the packets? Just go to town. Throw a few around. Go on.
I'm gonna stop this music there.
Please do. That would be heaven for my ears. All I can hear is just sorry, sorry.
I'm doing great. I don't know what's happening.
Oh, sorry. Tom is struggling. Oh my God, dude!
That was not me.
You threw it like one step.
That was honestly not me.
I should bring like a bowl next time, and you should throw the bowl just so that we can. Oh, I've got a Nerf gun. I've got many, and don't like. I've got a wall, but I've got one that shoots out like dog balls. That would shoot out. That would shoot out chocolates.
Surely.
Is that a weird thing to bring to a lecture?
I mean, it is the last true.
Heading out with my Nerf gun. All right, excellent. Hope everyone is just feeling great. Okay, let's do it. Let's insert some nodes and then we'll delete some nodes. Should we insert nodes first? Yeah, let's insert nodes first. Okay, insert a specified number into the, oh, I hate these middle of the linked list problems. I hate them. Assume that there is always going to be why did I have a middle of the list? I don't like this question. I know I told you to do it, but oh my God. I'm going to change this question. You've done an insert middle, haven't you? There is an insert middle. You've done insert middle. There's an even, odd number of nodes. It's a whole vibe. That would be a really harsh exam question. We have had it once. Okay, let's change this question. I've got one that's like duplicate every single node by inserting the same node after the original node. Hey? It's not too hard. You don't think it's 2 dots? No, it's not a 1. Anytime you insert a delete, it's not a 1 dot. Hints for the exam, you're never going to have a 1 dot with inserting or deleting a node. As soon as you have to manipulate make memory or delete memory, you've gone to 2 dots. Okay, shall we duplicate every node? I don't even think I have a starter file for it. Maybe I do. Oh. Here's one I prepared earlier. Okay, thoughts, ideas, suggestions. So let's say we've got a list 3, 4, 5, 6. Then what we want to be doing is doing 3, 3, 4, 4, 5, 5, 6, 6. So I'll duplicate every single node. Okay, what are we thinking? What are we doing?
If head is null, return null.
Okay, first up, if head is equal to null, then we're going to return null. So we're taking care of what happens when the list is empty. Okay, so this is... Okay, great. Straight away we're in the... Yep, what else should we do? How should we move through the list? Okay. People are starting to wane. Who is starting to get over this term? Just one person in the whole audience, really. 2 people, thank you. Everyone else is still doing great. Okay, you've asked for it, here we go. Did you raise your hands? Okay. Whilst current... Meanwhile, I just thought I saw a cockroach out of the corner of my eye. I did not, but things are not going well, clearly. Okay, here we go. I did find a dead rat in my backyard 2 days ago. That was really revolting. Okay, that was really a pointless story that I shouldn't have told, but there we go. How did it die? That is a very good question. There is a cat on either side of our house, and the cat keeps killing these rats and dropping them over the fence and won't go in to collect them because I've got 2 dogs. And then I have to worry that my dogs have touched the dead rat and then they're going to come and kiss my face. Okay, and that's that situation. Yeah, my biggest dilemma in the last week, dead rats. Okay. Okay, so what should I do next?
Make a node.
Let's make a node. Let's make a duplicate node. How should we create it? Let's malloc some memory for it. Okay, so what this line will do is it will create a node for us. The node has nothing inside it. I should put some things inside it. I should initialize this node. What should I initialize it to?
Set data to the head. Sorry, current.
Oh my god. Yep, here we go. I should get someone to come up and type. That would be fun. Okay. Okay, so I'm going to set the data component of this duplicate node that I've created to the current data. And I still have to take care of my duplicate
Current
next. And you are saying it's going to go to current next. Lovely.
Current next. Duplicate.
And then I'm going to move my node along.
That's gonna be a
Don't do that.
problem. Yeah, that's not gonna be a problem.
Oh, it might be a bit of a problem, might it not?
Let's go current next equal to duplicate.
Or will it?
Current next is current next next. No, you want to connect current to the duplicate one before moving on.
Oh, yeah, current duplicate and then duplicate. Yeah.
Okay, so, okay, for those of you playing at home, not with this row of seats over here, do you understand what the students are saying? This is, okay, so I'm going to just quickly draw it up so that you can see what the situation is going on here. So let's say I've got a list, and I picked up this pen and I forgot to actually do anything to it, so I'm just going to go here. Okay, so let's say we have a list, and the list is 3, 4, 5, okay, and then it will finish with a null. So let's say I've got this current and it's the head, so that means my current is over here right now. I've now created a duplicate node which is sitting somewhere over here, and the duplicate node, which is this one over here, now is going to have the same data as the current. So it's going to have a 3 in it, and the next over here is going to point to current next. So what I've done is I've done that, okay? So this is what my list now looks like. But what is it that I'm missing? I'm missing a connection still, and I'm missing this connection over here, where I will point my current to this duplicate node. Yep? Does that make sense? Yep, okay. So the connection that I'm missing is from my current next to my duplicate node. Okay, and will that work, do we think?
We need another step.
And we need one more step, don't we? Because otherwise we're going to get stuck in a little bit of a loop. Okay, and what should my next step be?
Current equals duplicate next.
Yep, current is equal to duplicate next, and the reason for that is because... Yeah, go on.
You skipped duplicate.
Oh, I did. Yes.
No, that's what you're doing.
Yeah, that's what I'm... Okay. So what I want to be is I want to go to this node over here. So that's why I'm saying that my current should now be this one over here. This is my duplicate. So duplicate next is this node over here, which is the node that I want. So that's why it's not current next, because otherwise it will move me to another 3, and then I'll get stuck in a little bit of a situation.
Current equal current next next.
Yeah, you could do current is equal to current next next. Okay, and then we are going to return the head. Yep, good. Okay, let's have a look what that does for us. Okay, good. That's an easy thing to fix. Nope, no one's paying attention. People are just slowly falling asleep. Okay, so I'm going to give it a list. So I'll go 3, 4, 5, and it's returning 3, 3, 4, 4, 5, 5. What else should I do? What else should I test? Null list. Okay, let's give it a list with nothing. It's going to return me nothing. What else should I test? Anything else?
Duplicates already in the list.
Yeah, let's test 3, 3, 3, 3, 3. That's a lot of 3s, yeah.
Could you have just condensed 24 and 25 into just duplicate equal current?
No, because duplicate has 2 elements in it, so I've got to initialize both of the elements. Yeah. 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 Okay, how are we feeling, Tom? Paul, thank you. Someone said they don't know what this question is asking us to do. Tom's explained that. Okay. Do people in here understand what it was asking you to do? That was an easier question. What about if that was like an easier 2-mark question? What happens if did not take, or one that we make up ourselves? Look at this. I'm ready for that. Delete the first node in the list that's divisible by 6. Here we go. Let's do that one. That's a nice one. Okay, so what that means is I want to go through a list. I want to find a node that's divisible by 6, and then I want to delete it. Okay? So let's say I've got a list that has inside it 3, 4, 6, 7. I want to traverse and I want to delete this node. So that means that I will no longer have that node in my list. Okay, oh, that made it all disappear. That's not what was my intention. Okay, thoughts, ideas, suggestions, how we would solve this one? Yeah.
Keep going until current next is 6 or will divisible by 6.
Yep.
Next data.
Yeah. So I want to be stopping at a previous node to the one I want to delete, basically, is the story there. Okay, so let's say struct node. Oh, okay. A few people were not sure. Going back to the previous question. A few people still getting their heads around it. Do you want me to run through the code of the duplicate one? Okay, Okay, for those online, do you want me to run through the code for the duplicate question, line by line? Okay, yes please. Okay, I'm going to go back a little bit because a third of the people did not understand the duplicate question. Okay, some people are saying yes, some people are saying no. I'm going to be super quick, okay? Here we go. Okay, this is what this part is doing. Okay, and move this down. And let's go to a pen and let me delete this. And I don't know why I'm commenting on every action I'm taking. Okay, so let's say I've got a list, and that list, that's not the right mouse, still commenting. Okay. I've got 3, 4, 5, 6, and then a null. So this is what my list looks like right now. So let's say this is the list that I've read in. Okay, so the first part of the question is if head is equal to null. Well, it's not. I've got a list. So I'm going to skip this if statement and I'm going to go down here. I'm going to create a current node that's pointing to the head of the list, which means that my current node is now going to be pointing to this node over here. That's now my current node. Excellent. I'll go to line 22. I should have done a shorter list. Whilst current is not equal to null, well, it's not equal to null, it's equal to something is in there, it's not null, which means I'll enter into this loop. I'll now create struct node duplicate, so I'll create another node, and this node is going to be called duplicate. So I've malloced some space for it, which means it's got the size of a node. And that's the best that I can do, okay. Okay, then on the next line, what we've done is we've initialized this duplicate node. So what I've said is, whatever is sitting inside duplicate data, could you please give it exactly the same as current data, because I'm trying to duplicate the node that I'm on. So my current is 3, and that means that 3 is going to go inside here. And then I'll go to line 25, and I'll have duplicate next. So where will this node point to? And what I want to do is I want to point it, because I'm going to insert it in here. And if I'm inserting it in here, I want to point my duplicate node to the number 4. So duplicate next, which is whatever is sitting here pointing to next, is going to be equal to current next. Current next is 4, which means that I've just established this connection here. Okay, that's great. So now what I need to do is I need to go from my original node to the node that I've just created to create the perfect connection. And that's what I'm doing. So my current next is now going to be pointing to my duplicate node. So it's going to point in this direction. And that means that this connection is now gone. So now my list is 3, 3, 4, 5, 6, X. And then what I do is I need to move along in this while loop. So what I'm doing is I'm setting my current to duplicate next. And the reason I'm doing that is because if I go current is equal to current next, what it will do is it'll take me to this node here, which is just 3, but I really need to be at the next node in that original list. So I could have also said current is equal to current next, which means I would have skipped the duplicate node and gone to the following node. So that would be exactly the same thing. And then I return the head of the list so that I know where I am at. Okay, I hope that cleared it up a little bit for all those playing at home. Okay, great. Let's go back to our divisible question. Okay, let's do this delete divisible by 6. Okay, so I'm going to have a struct node current. It's going to be equal to the head of the list. Okay, and then now I'm going to need to start traversing the list to look for this node that I want to delete. Okay, am I going to have whilst current is not equal to null or current next is not equal to null as my condition? Yep, current. That sounds good, because what if the last node will be divisible by 6? I will not find it if I stop. Okay, great. Okay, good. So that's me traversing the list. Now I really need to be able to actually find this node that I want to delete. How will I check for being able to delete this node?
one.
We could, yes, we
Checking
could
current
have,
data is equal to 6.
yep. So we could have a previous node as well. Is that what you mean?
Yeah.
Okay, that's a very good idea when you're deleting. Why is it a good idea?
Just need to reattach the.
Yeah, because I'll need to reattach it. And as soon as I find this current node that's going to be divisible by 6, that means I have no way of knowing what my previous node was. Okay, what should my previous be equal to if my current is head? Null, yep, because it's currently nowhere. Yeah.
But you don't need a previous node if you just go until the node before 6.
Yeah, I could also,
Yeah.
yes. It,
You
so,
have-
depends how you think through the problem. You can definitely move with current next, and you can stop previously to it, and you can check. But if you find it very confusing to have more than one next, then you can have a previous node as well.
And in the alternate way, you have to do current next is not wrong.
Yeah. Okay. Now we're moving through the list, and we want to be checking if we're divisible by 6. Okay, so let's check if current data modulus 6 is 0, that means we are good to go. We want to delete some things, we want to link in some things now. Should I give you a few minutes to try it yourself, see if it works? Ah! And then we'll do it together. Sorry, the microphone almost knocked. Just saw a dead rat. No, I didn't. I have seen a few on campus. Have you not? Rats. There's lots of cats on campus. Yeah. Yeah. There's literally rat poison trap at the bottom of the building. Okay, so 2 minutes, and then we'll do it together. I'll draw it up meanwhile. Hey? Oh yeah, no good.
The edge case that you did.
Yeah, I'm gonna do it in the middle first, then we'll talk, then we'll do edge case. Sis. So the question is asking you to delete the first node that you find that's divisible by 6. Oh, that was not, my chat was, who's done it? Anyone else? Is everyone waiting for me to do it? All right, I get it. Fine. No one wants to flip the classroom. Okay, oh, that's not what I wanted to do. Let's talk about, always with these ones, draw a diagram, okay? Linked list, draw a diagram. What a great opportunity to use that scrap paper you're given. Okay, let's say this is the node I want to delete. It's in the middle of a list. It is like the perfect conditions, right? You know, not real life, but that is a contrived question right now. Okay, so I'm going to keep going through this list. Great, I've gone into here, and what I have now, this is my current, that means, and this is my previous if I'm doing the right things in my code. Don't know why there's air quotes. So if current data modulus 6 is equal to 0, which it is, I now want to get rid of this node. Okay, great. Can I just free this node right now and call it a day? Can I just be like, all right, see ya. Bye. Can I do that? No. I mean, I'll do it at some point in time, but I can't do it straight up because if I just free this node, then I don't know where to find this 8. This 8 is now gone missing in space. So what I need to do is I need to reconnect my previous node to the one that follows afterwards. Yeah? Okay, so I don't know why it keeps disappearing the image every time. Anyway, so what I want to do is I want to connect my previous node. So the previous next node is going to be current next. That was just a... It's going to be current next, okay? So what that will do is it will say the next one to this previous one is going to be whatever's sitting after current next. Okay. Hey? Okay. So then I free the current, and because I'm only deleting the first thing, I am done with this list. So I am ready to return the head. Okay? Okay, fantastic. So that's great. I've got my if statement. What happens if the node is divisible? But now over here I've got this top while loop and watching you leave. And not even out the front doors to make it really pointed. Go on then. Okay, so we've got to do something in this loop, okay? The loop, something magical has to happen. We need to move the loop along. Yep. So I'm going to move the previous along. Okay, so we think something like this might work?
Without edge cases.
Without edge cases, absolutely. Yeah. Okay, so let's give it a whirl. We haven't, so that's the case where it's in the middle, and that's exactly what I'm going to do. So I'm going to compile. Okay, going to compile it. What have I done?
You have the other functions too.
Oh, God. Yeah. Called the wrong function. Oh. Okay. Let's try that again. Okay, no problems. Like it never happened. Okay, so now let's run it. And we're going to run it with that list that I had. And I've forgotten what it was, the number in the middle. So 368. And it deletes it, no problems. You think I've solved the question, I've got full marks, 12 marks are mine. I'm in for the win. How can I break it?
0. No nodes.
No nodes? Why is that working? Yeah, because head is null, so it's just returning null. Okay, how else can I break it?
If it's the first one in the...
Okay, let's try when it's the first one. And we've broken because we have this situation here, and we're trying to have this previous current, and that means we're dereferencing a null pointer because it's the first one, and previous right now is equal to null, so you can't dereference a null pointer. Okay, so how can I take care of that? Yep, I'll check before I start. So I'll say if my current data is modulus 6 is equal to 0, then what will I do? What that means is that now my 6 is over here, so it's like, let's say 6, 7, 8. So it means what I want to be doing is I want to delete the head of the list. So what will that mean? Yeah, so I just need a new head. That's become the next element. And what am I going to free? Yeah. Okay. So what I'll say...
Make a node called old head.
What?
Make a node called old head. Old head.
Sure. What should I make it?
Head.
Amazing. And then what will I do then? Okay, so that will move me along to the next thing. And then what should I do? Should I get rid of it? Beautiful. So now I'm going to get rid of it. Yeah, you return. Yeah, and I'm going to return the head now, which is now my...
Does that just imply there's only one? There's only six?
What?
There's only one thing you do?
Yeah, only one. Yeah. Should we try it now? Okay, let's try that, and then we'll run through it. Okay, yeah, that's working now. Yeah.
Couldn't you just make it n equals n next and free current instead?
Yep,
Opposed to,
I could do that.
okay.
Absolutely. Yeah. What else? How else can I test it? Just to make sure it's all going okay for me.
End of the list.
Let's do end of the list. Okay, so I'll do 9. Nope. Yep.
And it's not present.
Excellent. And let's do when there's nothing there. Yep. Okay, so we're, yeah, it's a party. Yep.
What about like 6, 12, 17? So you have 2.
Beautiful. Yep, absolutely. Because we're saying return only one thing. So what happens if there is everything that's divided by, yep. Okay, so that's working as well. And that's because we've got the right return. We're returning, so we're not continuing with the search. Good. Very good. Okay. Now, how are we feeling? Who wants to run through the code line by line? Only the people online are communicating that. No one in the audience has become too small to feel confident. Yep.
One more problem.
Couldn't head be null? It could be. We've checked it. Oh no, we didn't check it. Oh, I know why it doesn't work. Why doesn't it work now? Hey?
You're looking at current data.
Yes, exactly. So we've broken it because we've made some modifications, okay? Okay. Oh my goodness. If head is equal to null. Or you could return head, doesn't matter. Okay, good pickup, good pickup. Okay, we're back. We're back from this broken environment. Okay, who wants to run it line by line? Someone's saying yes please online. No one else is saying anything, so we're just going to do it. Okay. And how is everyone feeling about this type of question? This is like the question 6. I heard a good. I wasn't looking up though. Good, good. Yeah, excellent. Okay. Okay, I don't know why that's now gone over there. That's not even using the plot. Okay, great. Let's have a look if we have the perfect... Okay, someone's asking why do we need to declare new old node? So what I'm going to do is I'm going to make that case that happens if that is needed. So I'll go 6, 7, 8, and null. Okay, so over here we've got our current set to head. So this is my current, and my previous is null. So I'm just going to make it like an X here. Okay, great. So now we've got if head is equal to null, it's not, so we're going to skip that. We're going to move on down to here, and we're going to say if current data, so if this 6, modulus 6 is 0, which it is, so we're going to go inside this if statement. What we're going to do is we're going to create a variable called old head, and we're going to store the address of the head in it. So what we've done, let's say the address of this is at A. What we've done is this old head is now going to be the address that is inside our head. Okay. Then what we've done is we said head is actually now going to be equal to head next. So this is my new head over here. And then I'm freeing old head. So what I'm freeing is this address over here. So I've just freed that node and I've returned my new head. So I've returned this, which means I've returned where the list has started. Okay, yes, you can do it in another way as well. you can also do, quite a few people have now asked it, so I'm just going to pop it in here as well. You can also do head is equal to current next, because current was already set, and then you can free the current and then return the head. Okay, so you can do it like that as well. It's doing exactly the same thing. Whichever way makes the most sense to you, okay? So whatever makes the most sense to you. Yeah.
Can we do a question where we have to like free multiple things?
Sure. Sure, why not? Oh my god, it's 12:53. In the exam, for those that are in the audience, it is highly unlikely in a question, in the first, like, in question 5, 6, 7, 8, you will have to free multiple things. It will always stop you at one, because we are conscious that there is time limit in the exam. However, when you move on, you might have to do multiple things, because if you have moved on, then you are ready for multiple things. How would you do this question if you had to delete multiple nodes? Yeah, so you don't return, but you'll just keep looping through it and finding a node that is delete, delete, and then you just keep deleting them. Okay, and something you can try, if you want, put it on the forum, I'll have a look at the code and then I can respond as well. I don't know, where did the time go? Who stole time? It's, hey? Have we got any chocolates left? All right, just distribute them, and we're going to finish there. Let me know if there is anything that you want to do in particular on Thursday as well, except for pointers and strings. And feel free to post on the forum. You can even do it as anonymous. Just post if there's anything in particular you want to go over, okay? Do you have to? Leak check.
When does exam registration come?
You'll